Hello and welcome to another video. In this video we're going to be working on find the minimum and maximum number of nodes between critical points. And in this one you have a critical point that's either a local maximum or a local minimum. And it's a local maximum if it's greater than the previous and the next node, and a minimum if it's smaller than the previous and next node. Note that it can't be both. And so given the head of a linked list, return an array returning the min distance between any two critical points and the max distance between any two critical points. Or -1, if none of them, or there have to be at least two. So in this example, there are none. So you just return -1, -1. In the second example, let's take a look where they are. So this is a local minimum, and then this is a maximum. This is a minimum, and I think that's it. Yeah. So the distance, the farthest distance between any two critical points is always just going to be the first point minus the last point. So here it's 1, 2, 3. And then the closest is these two right here. So you return 1, 3. So in the last example, this is a critical point. This is a critical point. And yeah, that's it. So the min and the max distance are the same, and they're just 3 and 3. Okay. So how do we do this problem? Like, let's say we have this linked list going to the right and we have a bunch of points. So how do we compare a point? Like let's say we had an array, right? If this was just an array, then what would we need instead of a linked list? Well, we can just check, is it a critical point? And like I said, the max distance is always going to be the distance between the first point and last point, right? So we can just record those. Like whenever we reach the first point, we'll store that. Whenever we reach the last point, we'll store that. But what's the min distance? So the min distance between critical points is always going to be between two points that are next to each other, right? So if you have a bunch of critical points, like let's just say we have the array example, like let's just say we have a point, here, 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 and here or something. The minimum distance is always going to be between two points that are next to each other. So like these two or these two or these two, because it can't be like this, right? Because this is always going to be further than points that are right next to each other. So now that we know that it has to be points that are next to each other, all we have to do is just keep track of one point that we stored. So for example, like let's say this is a point and this is a point and this is a point, let's say. When we reach this point, and I'll talk about how to compare it to pretend this is an array again. We're gonna store the index of this point, and then when we reach the next point, we're gonna say, okay, what's this index minus the last one we've seen? So this index minus this guy. And is that smaller than our min distance so far? Then whenever after we calculate that, we're just going to store the index of this point. And then when we go over here, we're going to say like, okay, for this index, what's this minus the last one we've seen, which would be this one. So all we have to do is keep track of two things. We have to keep track of the first point we've seen and the last point we've seen. And then from there, like I said, these two will tell you the max. And then to tell you the min, every time you reach a new point, you just do that minus the last point we've seen. What's that distance? Is that smaller than my overall? Okay. So now, how do we, because this is an array, this is a linked list, when we're on a point, we need to be able to compare it to the one before and the one after, right? And there's kind of like two ways. One, we can just simply store the variables or something, right? Like we can just go one by one, and we can just keep track of the point before in a variable. But the other way is we can just use, instead of going through the points, we can keep track of the current node and the previous node. So what will happen here is this will be like the head of the linked list. We're actually going to start over here. So we're going to start at the second node of the linked list and the head of the linked list. So this will be like our current node, and this will be our previous node. And then we have access to the current node, the previous node, and then the next node is just a pointer because it's a linked list. So we could say while the current node's next value is not none, right? Because for a node to be a local minimum and maximum, there has to be a node after it. So we can say like while this node still has one after it, let's take this value, let's take the one after it, and let's take the value that this pointer points to and compare all those and check, is it a local maximum or a minimum? And then as we move them up, we can just move them up together. So we'll say like current equals current next and previous equals pre next. And we can keep moving them up until finally we get to here. And this will be the last time we'll be able to check. But then once we get to this point, the current node no longer has a next pointer, so this can't possibly be a maximum or minimum. Then we just check, like, did we actually find any points? Like, did we have a first and last value? Are they different? And so on. and then we can just return -1, or the whole thing. So that's all you really need is to find, like I said, in an array, if you have a bunch of points, the closest distance between 2 points will always be 2 points that are right next to each other. So all we have to do is just keep track of the last point we've seen. We don't need to keep track of that whole array. We can just traverse and do this in linear time and in a one pass. Okay, so that's what we're going to code up. So let's do that. So we're going to keep track of a few things. First, let's make a result array. And so the first value is going to be the minimum distance, so we can just initialize it to what's it called? Infinity. Because we're trying to minimize. And the second value we're trying to maximize, so we'll make it negative infinity. Or I guess not negative. Well, I think integer min value is negative infinity, basically. So yeah. Okay. Then we're going to have, the other thing is, for this linked list, like, we actually need to know where this was, right? Because in an array, you have an index. In here, we don't have an index. So we can just say where we start is index 1. So we'll just say, like, this is index 1, and then every time we move our pointer up, we'll just increment the index. So this will be like 2, 3, 4, 5. That way we'll know the location. Okay. So we'll say int I equals 1, and int first location, the first, like, thing we've seen, the first local minimum maximum, we'll say it's 0, and this will be like if we haven't seen it at all, because we're going to start at index 1. So if we haven't seen it, it'll be here, and then if these values get updated, then they won't be 0. Then we just need the current and the previous, so this will be head next and cur, or this node previous equals head, or you can just use the head directly. So you can say while current next does not equal null, right? The current node needs to have a next and a previous to be a local maximum or minimum. Then we need to actually check, is it a local maximum or a minimum? So let's check first if it's a local maximum. So if current val is greater than current next val, and current val is less or greater than a previous val, right? It has to be greater than both. Or we have the other version where it's less than both. So we can just copy this guy, change these two signs, and we have access to all three of these as we go. Okay, so if this is the case, we need to check, are we on, like, we don't want to compare the distance of a node to itself. So what we really want to find out is this the first node we've seen? If it's a first node we've seen, we just want to initialize these two variables. So we can say, if it's not the first node we've seen, if first location doesn't equal 0, then it's not the first node we've seen. So then the minimum distance is going to be, which is this first guy, is going to be either the value that it previously stored or the current index minus the last node we've seen, right? Because the only node we need to compare this node to is the last node we've seen, because we're only going to compare adjacent nodes. So this is going to be last location. And the biggest distance we've seen is always going to be this current node minus the first location, right? It's always going to be the last node we've seen minus the first node we've seen. And the last node we've seen so far is this one right here. Okay. Otherwise, this is the first node we've seen, so then we just want to initialize those. So we select first location equals I. And the last location, we don't need to initialize here. We're always going to change that to this current node, no matter if it's the first node we've seen or not. So we'll say last location equals I here. Because even if we have seen nodes before, the last location is always going to be the last node. It's going to be like the last node we've seen, which is always going to be the one we're currently on. Okay, now we have to, regardless of if this is the case, like if this is not a local maximum or minimum, we don't have to do any of that. But we still have to increment I, and then we still have to move over pointers. So, and finally, we have to check, did we actually ever modify the result? So if we didn't modify the result, we just wanted to return that -1, and if we did, then we want to return the result. So we can just say, is the result 0 still equal to integer max value? If it has, we haven't actually seen two local minimums yet, or maximums, minimums, whatever. We haven't modified the result. We haven't found a solution, so let's just return that -1. Otherwise, we can return the result because it's valid. And so if this is not integer max value, then this won't be either. But that means like both of these will be valid. So yeah. So pretty easy one, I think. Let's see what we did wrong. Okay, so it looks like for this, there is a, let's see, there's a local minimum here and a local maximum here, and we're still returning -1. So that's not correct. So let's see what we did wrong. So this is fine. If curvel, this is fine. And this is fine. Oh, this needs to be, this can't be and. It's one or the other, right? It's either a local maximum or a local minimum. It can't be both. Okay, there we go. And so time, this is linear, 1 pass, and space 1. So we can double check this guy says. Yeah. Okay. So yeah, the main thing to recognize in this one, once again, basic linked list traversal, and know that like if I'm at a value, I don't have access to the previous node, so I either have to store that value, or I have to have another pointer point to it. Is going to be the way to do it. And yeah, if you have a bunch of nodes of interest, the shortest distance between two nodes, it's always going to be two nodes that are right next to each other. So you can just check as you go, nodes that are right next to each other, what's that distance? You only need to store one variable there instead of storing the whole array of every single node. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.